Hey everyone, welcome to Z Academy, your go-to place for smart, simple, and exam-focused physics lessons. If you're new here, don't forget to subscribe and tap the bell icon so you never miss a topic. Now let's begin. In physics, we often measure things like distance, mass, or time. But simply saying 5 or 10 isn't enough. We must mention what we're measuring in. That's why we use units. A unit is a standard quantity used to measure a physical quantity. For example, if we say a rod is 5 meters long, then meter is the unit of length. Without units, the number has no meaning. Saying the mass is 10 feet is incomplete unless we say 10 kilograms. Characteristics of a standard unit. A unit must be reliable. For that, it must have certain important characteristics. Well defined, it must be clear and precise. Invariable, it must not change with time or place. Easily reproducible, it should be possible to recreate it in any lab worldwide. Practical, it should be easy to use for measurements. Universally accepted, scientists everywhere should agree to use it. These features make sure that all scientists measure the same way. The International System of Units, SI units. To make measurements the same everywhere, scientists developed a universal system called the International System of Units, or SI units. It was adopted in 1960 and is now used all over the world in science and engineering. The SI system is based on 7 base quantities, each with its own standard unit. Length, unit. Meter, m, mass, unit. Kilogram, kilogram, time, unit. Second, s, electric current, unit. Ampere, a, temperature, unit. Kelvin, K, amount of substance, unit. Mole, mole, luminous intensity, unit. Candela, CD. These 7 base units form the foundation of all measurements in physics and other sciences. Let's look at some cool examples of derived quantities, and don't worry, we'll explain each one like we're telling a story. Area. If you want to know how much space something covers, like a carpet or a football field, we measure its area. Area is length times width. That's length times length, and boom. That's a derived quantity. Its unit is square meter, written as m squared. Volume. Now, what if we want to know how much water can fill a bottle or a swimming pool? That's called volume, how much space something takes up in 3D. Volume is length times width times height equals m cubed, which means cubic meter. Speed or velocity. Ever raced your friend and wondered who was faster? That's where speed or velocity comes in. It's how much distance you cover in a certain time. So its length divided by time equals meters per second. Acceleration. Now let's say your car goes from slow to fast, that's called acceleration. It means your speed is changing. We calculate it by speed divided by time equals meter per second square. Force. Ever pushed a heavy box and said, wow, that's tough? That effort you used is called force. It depends on how heavy the object is, mass, and how much you're speeding it up, acceleration. So, force equals mass multiply acceleration equals kilogram per second square. That's also called 1 Newton. Pressure. Now, let's say you press your finger on a balloon. You're applying pressure. Pressure is force decided by area equals Newton meter square, and that's called Pascal. Density. Ever seen oil float on water? That's because they have different densities. Density is mass divided by volume equals kilogram per meter cube. Work or energy. If you lift something up or move something, you're doing work, and that uses energy. Work equals force multiply by distance equals kilogram square meter per square second. And the unit is called Joule. Power. Want to know how fast you're using energy? That's power. Power equals work divided by time equals joules per second equals watt. Writing units as powers of 10. In physics, we often write measurements using powers of 10. This is called scientific notation. It helps us write very large or very small numbers more easily. 1 kilometer, km, equals 10 to the power 3 meters equals 10 to the power of 3 m. 1 centimeter, cm, equals 10 to the power minus 2 meters equals 10 squared m. 1 millimeter, m, equals 10 to the power minus 3 meters equals 10 cubed m. This format is very useful when converting between units and performing calculations. If you enjoyed this video and learned something new, give it a like, and don't forget to subscribe to Z Academy for more clear, simple, and exam-focused physics videos. You're doing great, stay curious, stay confident, and we'll see you in the next one.